to do a review of slope. But before we could talk about slope, we have to define two words really quick. The Cartesian coordinate system. If you look to your right, you will see the examples of the Cartesian coordinate system. Notice we have two axes, the x-axis and the y-axis. You've probably used this before. Hopefully this is review. The other word we have to define is ordered pair. An ordered pair is basically the instructions to find any point within the coordinate system. So for example, the points that we have marked on line number 1 are -1, -1, and -3, -2. Oops, I did that backwards. It's an easy mistake to make. -2, -3. Why was that a mistake? Well, notice we keep our ordered pairs in the order of x and y. So we move in the x-axis first and then down in the y direction. If you're having a hard time remembering how to do ordered pair points, feel free to email me and ask for help. I'm happy to talk you through that in a little bit more detail in another video. Today we're talking about slope, though. Another word for slope that I want you to know is rate of change. If I could spell the word rate, that would help. The slope or rate of change describes the steepness of a line. We normally assign that a numerical value, the steepness of a line. We did talk about slope as terms of the change of y, or the change in the y direction, over the change of x, or the change in the x direction. That's sometimes frequently known as the rise over the run. So let's go look at number 1. First, let's pick our point. Let's start here at -1, -1. Okay. How much do we change in the y direction? Well, we go down 1 unit, and then we go down again. So we change -2. Now let's consider the x direction. We're here, we go over to the left 1 unit, or we go from -1 to -2, which is subtracting 1. So our rise over our run would be -2 over -1, which is the same thing as 2 over 1, which is 2. Let's go ahead and do another example. Number 15. I've removed the line from between the 2 points just to make it a little easier to see. So let's start at this point right here. It doesn't matter which point you start at. You should be able to get the same answer regardless. So here we are. We're going to start at this point. Let's go down in straight lines to the other point. Well, we go down 1 unit, 2 units. So that's -2. Now we're along here. We're going to go 1, 2, 3, 4, and we're moving to the right, which is the positive direction. So this is 4, giving us -2 over 4 for our change in y and our change in x, otherwise known as -1/2. We also have a formula that we can use in case our points aren't graphed. It's called y2 minus y1 over x2 minus x1. This is going to be from 2 points. We have x1, y1, and x2, y2. You'll be given 2 points. It doesn't matter which one's the 1 point, x1, y1, or the 2 points, x2, y2. It doesn't make a difference so long as you're consistent about them. let's go ahead, we'll just look at one of your homework problems. Let's look at number 4. We have -5, 3, and 19, 19. Okay. It doesn't matter which one we declare as x2 and which one we declare as x1, so long as we're consistent. I generally like to do x1 is the first point that we see. So x1, y1, and x2, y2. So now we'll just plug that into our formula. We end up with 19 minus 3 over x2, which is 19, minus -5, which gives us 16 over 24, which is the same thing as 2 over 3. It works fairly simple. It's pretty slick. Practice. If you need more help, feel free to email me and ask for clarification.